Hello everyone, in this video I'm going to discuss the example for differentiation, especially for the implicit differentiation. Given we have the situation xy minus the sine bracket xy minus the 3 equals to 0. Number 1, they ask us to find the dy dx in terms of x and y. So make use of the product rule. We have y, differentiate the x, and we have 1. Plus x, differentiate the y with respect to x, so we have the dy dx. Then we have negative, differentiate the sine, and we will have the cos bracket xy. Focus on the internal function. Again, product rule. So here we will have y, differentiate the x, and we will have 1. Plus we have x, differentiate the y, and we will have dy dx. Continue, differentiate the negative 3, and we will have 0. So kindly rearrange the situation and then focus on the dy dx. So here we have y plus with the x, we have the y prime. Minus, if we expand the situation, and we will have y cos bracket xy. Minus, we have the x cos bracket xy, and then we have the y prime, which is equals to 0. So focus on these part. So here we have the y prime, or the dy dx, bracket, we have the x minus the x cos bracket xy, equals to, rearrange the situation, we have the y cos bracket xy, and then minus the y. So next we have the dy dx, which is equals to, if we factor out the y, and we will have cos bracket xy minus the 1 over, we have the x bracket, we have 1 minus the cos bracket xy. So notice that we have the common terms if we factor out the negative. So here we will have negative y bracket 1 minus cos bracket xy over, we have the x bracket 1 minus cos bracket xy. So notice that we have the common terms. So we can simplify, and as a conclusion, the dy dx, which is equals to negative y over x. So that is the answer for number 1. So number 2 shows that we have the x multiplied with the second derivative plus with the 2 multiplied with the first derivative equals to 0. Let's begin on this part. We have x multiplied with the dy dx equals to negative y. So focus on the left hand side, we have the product rule. Dy dx, multiply the x, and we will have 1 plus x, differentiate the dy dx, and we will have the second derivative equals to negative dy dx. Rearrange the situation, we have the x multiplied with the second derivative, and then plus we have the 2 multiplied with the dy dx, and then equals to 0. And notice that we already shown the situation given. Hello everyone, in this video I'm going to discuss the example for differentiation, especially for parametric differentiation. Given the parametric equation where we have x, which is equals to ln bracket, we have the t squared, and then plus with the t. Continue, we have the y where we have t squared plus with the t bracket, we have the power 1 over 2. For t greater than 0, find the first derivative and also the second derivative in terms of t. Hence, evaluate the second derivative when x is equals to ln 2. So based on the situation given, if x is equals to ln 2, meaning that we have the ln 2 equals to, we have the ln bracket t squared plus with the t. Next, we compare the situation. We have the t squared plus with the t equals to 2. T squared plus with the t minus with the 2 equals to 0. If we factor the situation, we have t plus with the 2 multiplied with t minus with the 1 equals to 0. So t is equals to negative 2, t is equals to 1. Kindly refers to the question. They mentions that t must be greater than 0. So t equals to 1 would be valid, but not for t equals to negative 2. Continue with the situation. In order to find the dy dx, what we have to do is to differentiate the x with respect to t. So dx dt 1 over t squared plus theta t multiplied with the internal function, we have the 2t plus theta 1. So if we simplify the situation, and we will have dx dt 2t plus theta 1 over the t squared plus theta t. Focus on the y, we have to find the dy dt. We have 1 over 2 bracket t squared plus theta t negative 1 over 2, and then differentiate with the internal function where we have the 2t plus theta 1. Kindly rewrite the situation dy dt where we have the situation in here 2t plus theta 1 over 2 multiplied with the square root t squared plus with the t. Next, find the dy dx where we have dy dt multiplied with the dt dx, meaning that we have to flip the dx dt. Kindly substitute the situation. So we have the 2t plus theta 1 over 2 square root t squared plus with the t. Multiply with, we have the t squared plus with the t over, we have the 2t plus theta 1. Next, if we simplify the situation, so here we can make it become 1. So here we can make it become 1. Next, if we simplify the situation, so here we have the t squared plus with the t, or we can say bracket power 1 over 2 t squared plus theta 1 bracket power 1 over 2. If we simplify, so we will have the square root of t squared plus with the t over the 2. That is the dy dx. Next is to find the second derivative. So the second derivative, the formula would be differentiate the dy dx with respect to t, and then multiply with the dt dx. So what we have to do is to differentiate this part, and we rewrite the situation. So we have t squared plus with the t bracket 1 over 2. Here we have 1 over 2 dy dx. So if we differentiate the situation with respect to the t, so we will have 1 over 2 multiplied with 1 over 2 bracket, we have the t squared plus with the t power negative 1 over 2, differentiate the internal function 2t plus theta 1. If we rewrite the situation, and we will have this part, we have the 2t plus theta 1 over, we have the 4 multiplied with the square root of t squared plus with the t. That is the situation for this part. Do remember, multiply with the dt dx, where we have to flip the situation, t squared plus with the t over, we have the 2t plus theta 1. Simplify the situation for the second derivative. So where we can have the common terms, so it become 1, and then continue, we have the situation t squared plus with the t over 4 multiply with the t squared plus with the t. If we simplify for the second derivative, and we will have the answer square root of t squared plus with the t over the 4. So that will be the answer for the second derivative. If we refer to the question, we already find the dy dx and also the second derivative. Next is to evaluate the second derivative when the t is equals to 1. So the value for the second derivative, and we will have the square root of 2 over the 4. So that is the value for the second derivative, or we may express the situation 0.354 for 3 significant figure.